Welcome to today's Advanced Manufacturing Media webinar. Our topic is Advanced Manufacturing and Using Big Data to Enhance Production from Big Shops to Small Shops. Hello, I'm Pat Wozniak, Senior Editor at Manufacturing Engineering Magazine, which is part of SME's Advanced Manufacturing Media. My beat includes covering developments in CNC controls, automation, and manufacturing software. Before we begin, I'd like to provide some background on what we'll be doing today. Our sponsors include Geometric CamWorks, CG Tech Vericut, Delcam, Plex, Shopfloor Connect, and Verisurf Software. You'll be able to ask questions after the presentation using the Q&A box that appears on the right side of the screen. Time permitting, these will be answered following the presentation. If time runs out before we can get to all the questions, we'll make sure the answers are emailed to you. If you experience difficulty during the presentation, please let us know via the Q&A app. And if you have questions about any other aspects of our webinars, please email me at pwozniak@sme.org. I'll rejoin you after the presentation with a few concluding remarks. Thomas Kurfess, our presenter, is the Husco Ramirez Distinguished Chair in Fluid Power and Motion Control at the Woodruff School of Mechanical Engineering at Georgia Institute of Technology. Professor Kurfess started his academic career at Carnegie Mellon University and later was Professor and BMW Chair of Manufacturing in the Department of Mechanical Engineering at Clemson University's International Center for Automotive Research. He recently served as the Assistant Director for Advanced Manufacturing in the Office of Science and Technology Policy in the Executive Office of the President of the United States of America and was the technical lead for the President on current federal efforts related to manufacturing. Now, here is Thomas Kurfess.
Thanks, Pat. I appreciate the introduction, and good afternoon to everybody. It looks like we have a pretty good group online here. I'm going to be talking about big data in terms of enhancing production and so forth as it relates to advanced manufacturing, and really in terms of an overview of where we're going, and not in any particular order. This is going to be really woven through the entire talk. Is we're going to we're going to talk about, I think initially it's always good, I like to kick off these things with talking about manufacturing and its importance, why we're here in the whole bit. And I know I'm preaching to the choir, but I just can't help myself. Manufacturing is good stuff. We'll talk about really some of the tools that are out there. What does big data mean? Where does it really fit in there? I think it's worthwhile in terms of, big data sort of fitting in with things like the cloud. We've got the silver lining, but I really think we're really mining the gold out of this cloud. And by mining in general, you can think about data mining. And then finally, how it might sort of all relate to this digital manufacturing, because that's really where we're going. And then I'll wrap up with some realities about the future. All of this is great and so forth, but what does it mean from a technology perspective, from a workforce perspective, and so forth? And so we'll go through that. And again, feel free to punch in your questions, and Pat and team will be monitoring those, and we will do our best to get to those as we're moving along. So start off, and if some of you have seen me talk or some of my colleagues talking, and you say, well, gee, why is manufacturing important? Well, really, the bottom line is people can talk about, well, we have a great design or a great idea or a great concept. If you can't scale it up, if you can't produce lots of them, thousands, hundreds of thousands, maybe even millions or billions, then the idea, the concept, the design, sort of the research and development might not be particularly useful to society. Certainly might not make significant amounts of money, right? So 70% of the R&D in the U.S. is really driven, by the manufacturer. I can make it, I can get it out there concept, and 90% of the patents that are issued relate back to manufacturing, whether it's a product that has to be manufactured and so forth, but certainly the value is there. Time and time again, we've demonstrated a very close connection between research and development, design, and manufacturing. If you're going to really be able to move things forward, to design, a good next generation product, to develop next generation capabilities, you really need to know how you're going to make it, how it's going together and the whole bit. Just the overall health of our industrial commons, just our know-how, the process engineering and so forth, even the workforce skills, these are all tied very closely to manufacturing. And by the way, the other thing I think is very important, we need to remember this, is you've got the OEMs out there, let's say a General Motors or a Ford, a Boeing, sort of the big companies, but you have their suppliers as well. Certainly the tier ones, but down to the tier twos, tier threes, the small and medium-sized manufacturers, the so-called SMMs. For every one OEM job, you've got 8 supplier jobs just in general. So, it's very important throughout the entire supply chain. Certainly, from an economic perspective, every dollar of manufacturing output generates $1.40 for other sectors of the economy, whether it's over in the service sector or, whatever it might be. So it's got a significant leveraging effect as well. And of course, in terms of the nation's economy, when manufacturing happens here in the United States, dollar of manufacturing, that's $1 less that we're importing, or maybe $1 more that we're exporting, but that certainly helps in terms of our trade balance. And finally, of course, from a national security perspective, it's important that we manufacture here in the United States, that we can depend on producing products here, within our borders. So, if we take a look at the big picture, in terms of manufacturing in the United States and sort of how the federal government looks at it and what are some of the big things that are going on, what you see here is on the right is this sort of big picture for manufacturing. And on the outside, we have things like human welfare, clean energy, next generation workforce, national security, and they really relate to, again, really 2 things in terms of the health of the country, and by the way, the health of the world, and that would be the economy and security. And all of these things are related. So that's kind of the big picture. On the inside, what we see are key areas for research, development, and engineering. And in general, we look at things, and these would be these 3 little balls in the center, the experimental tools, computational tools, and digital data. And, how this works is we move more towards, let's say, simulation and so forth, over time. And those computational tools allow us to do better and better in terms of simulation. But the reality is our simulation, our computational tools are only as good as some of the experimental or empirical data that we have. For example, what is the modulus of steel, or what's the thermal conductivity of aluminum, and so forth. So those types of things, we have to go to experiments and really run some tests, and they go back into our modeling systems. In particular cases, it might be, hardness of a material and so forth, or it might be machinability of a material. And so we run experiments, they generate digital data. Those data are then used in our computational tools to improve our understanding of various processes. And of course, it goes the other way around too. If we have new materials, our computational tools will tell us, hey, here are the experiments we need to fill in our unknowns in terms of our data. But the idea really, computation, experimentation, and I'm an academic, I think about experimentation, but it's also basically, hey, I've got a new material coming into my shop. What feeds and speeds and tooling should I use? What kind of depth of cut? What kind of machining parameters? What works well, in terms of coolant? Should I use a synthetic, non-synthetic, oil-based, water-based, et cetera, et cetera? Can I get away with maybe not using coolant? So all of these things, we're looking at. Now, then we sort of insert there, you see materials innovation infrastructure. So I actually got this from the Materials Genome Initiative out of the federal government. So the idea really is we've got the big picture on the outside. We've got a set of tools, computational experimental tools, digital data on the inside, and then they're really going to be supporting specific initiatives. In this particular case, I'm showing materials innovation. So that's the materials genome initiative. If you look at the list on the left, and that particular initiative is saying, well, gee, how do we develop new materials in half the time? A couple of the other big initiatives that are going on, top one there is the National Network for Manufacturing Innovation. So that's this big network for manufacturing innovation, and they're looking at, there are several centers that are out there right now. If you are not spun up on them and you want to see really what's going on in terms of interests of the nation, I would recommend to go to manufacturing.gov and take a look at the different centers that are up there. There's additive manufacturing, there's digital manufacturing, we have a lightweight metals area, we have a power electronics and so forth. So there are a lot of different areas that are going on out there. And in fact, actually, in particular, I think the digital manufacturing area is quite interesting for what we're talking about today. And then they're just announcing a future center on smart manufacturing. So how do you integrate sensors and things like that? We've got the robotics initiative that's going on out there. Again, this is using robots out in a wide variety of areas, but certainly we see them out in manufacturing. Additive is another big one. We talked about additive. We've talked about it certainly at SME in the past. And the one we're going to focus on today is big data. And so let's just go to our next slide. And the issue with big data, is okay. I want to collect, send and then make use of data, right? And I think the important thing here is to understand what this really means. So all of your, if you, and we see here, in terms of under the shop floor visibility and so forth, it's all, we've got the screen there with information, and that could be coming off of your machine or whatever, but certainly that machine tool back there, it's got encoders, it's got, monitors on it and so forth, could even easily have spindle vibration monitors, things like that. Actually, a vibration monitor might be something as simple as an accelerometer. And if you think about it, these sensors are pretty inexpensive nowadays. Probably if you have a smartphone, and I'm holding my little Android over here, it's got an accelerometer in it, right? So, it can pick up vibrations, it knows which way you're holding it, right? So when you rotate the screen. So these sensors are everywhere. They're ubiquitous, all right? So the most important thing to understand here is this issue of big data. Well, what's it going to cost to, quote unquote, censor up our factories and put all this together? It's already there. That information is out there. Machine tools, your systems out there, they have lots of information floating around them, all right? And so the real question is, how do you capture those data sets, and then how do you get them out? And then once you get them out, how do you use them? And in fact, typically, you're probably generating terabytes of data. Just a nominal size plant is generating terabytes of data, on a daily basis. And the question really is, how do you bring it all together? And the reality is that we might look at something like, well, on an individual machine, maybe things like feeds and speeds or tool wear and so forth, but it's a little bit bigger than that. In fact, actually, it's a lot bigger than that. So it's one thing to say, yes, I understand what my machine is doing, but the real question is, what my machine is doing here and now, how is that going to affect other aspects of the process down the line, and really linking it together. And again, if we go back and we take a look at our lives today in terms of how information technology has really changed us, it's pretty amazing, because if I'm going to go off, let's say, on a trip, before I go on my trip, I might check my flight online, find out what's going on with the plane. Is it on time? And now you can actually click on the plane and find out where it's coming from and if it's landing on time. You might check the weather. You might take a look at traffic. You might take a look at all sorts of different things that are going to affect your performance there. So not just, well, what time is my flight leaving, but lots of other things. And it's the same thing here. Of course, when you look at this thing, you've got your shop floor. You've got your visibility there. somehow you've got to get it off. And again, data are already there. Sensors are there. How are we going to get the data off of the sensors, and then out, and then stored somewhere? And here we have a little cloud with our, analytics and so forth. And then how are we going to take all that information and really analyze it? And again, it is really more than just saying, well, yeah, I'm going to analyze things in the way I used to look at it, picture, and I'm going to understand how the overall operation of my shop works. And then to make some informed decisions, right? Which way should I go? How am I going to move forward and so forth? And then the bottom line, though, is really, it's great for the user, but entirely new industries are going to really crop up in terms of really helping to make some of the big decisions and really to make life a little bit easier. And we'll give you some examples of things that people are very familiar with. But again, the exciting thing is that now, as a small or medium-sized manufacturer, I have the capability to really reach out and capture a lot of this information and have somebody analyze it for me and provide me with input. So let's click over to the next slide. And again, the idea is, what kind of things can we see in terms of, connections and so forth? Well, first thing we have to do is I think many of us have used all sorts of different types of machines and machine tools and so forth. We really need to take a look at how are we going to communicate on a very standard basis. You take a look at your computer. Your computer is probably either plugged into the wall or has Wi-Fi going on, and we're running on Ethernet. This is a very ubiquitous standard. And so we can move the information around, so forth, and really link things together. And there are some pros and cons, and we'll touch base on it. But a key thing here really is to understand that we are moving towards a very standardized scenario. Some of your machines may have relatively closed architectures. The newer ones, and we'll talk about that, are moving more towards open information that they can exchange data and so forth. They can do metrics. They can do cost analysis. It's easy to integrate them. Many of our machines now are online. Of course, we'll hit on some of the issues about security in a little bit. But this allows us, all the way from the shop floor, all the way down, and we sort of see in terms of getting data from an individual tool up to the machine tool, to the line, to the plant, to your entire enterprise, and sort of really moving that data in and out. Now, the real question, of course, that you have to look at is, how do you zoom in and out? It's sort of like if you go to Google Maps, right? Look, if you're looking at the United States and you just see the interstates going across the United States, you're probably not particularly interested in the traffic flow, on those interstates, where's a traffic jam and so forth. But as I zoom in, so I'm sitting here in my office in Atlanta, as I zoom into Atlanta because I'm thinking about going home and it's rush hour, I want to see where the red spots are, right? In terms of that, in terms of that traffic and so forth. And so you say, all right, I can zoom in and zoom out, and there are different data levels and so forth that I want to know. And by the way, as I zoom in more and more and more, in fact, my system knows that I might, go to Starbucks for a cup of coffee, so it's going to highlight where all the Starbucks are for me. The question you have to ask is, how much information do you want to go out? And people worry about security and privacy. But I can tell you, when you bring on Google Maps, you've agreed to a lot of different things, right? The first thing you do when you get your new phone is you load Google Maps on. When you run it, it asks you a bunch of questions, and usually, and I watch people do this, they hit OK. They don't really worry about what they're agreeing to, and then Google Maps is up and running. And you basically said, yeah, I'm agreeing to you tracking me and understanding what's going on and so forth. And again, that's fine, right? And this is something that's important for Google to be able to do. If you do your traffic, right, and you see the red and the yellow and the green, how Google is getting that is it's watching phones moving down the interstate, right? And if the phones are moving, more than 50 miles an hour, it's going to be a green segment on the roadway, and so forth. But the idea really is to be able to present the data at the right level. It might be for a machine tool, what's my uptime? What's my utilization? It might really be at the individual tooling level. How long is this tooling lasting and so forth? But you've got to have this connection. You've got to be sort of enable it via standards and so forth, and to be able to move it back and forth. So let's talk a little bit about how we would move this back and forth, and sort of what it really looks like. So The data generation I'm not so worried about. We start with collection. So data generation, I think, is relatively straightforward. Our machines, our automation and so forth has sensors on and off we go. So we can generate a lot of data. The real question is, well, once you've gotten it, how are you going to move it forward? And I borrowed this slide from our colleagues over at MT Connect. And basically it's one of the standards that are out there that allow us to exploit the digital data. So it is just a one-way, connection that allows the data to flow off of your machine, off onto the IoT, the Internet of Things, right? So this is basically, and again, people say, well, everything is going to be on the Internet and so forth. Yes and no. Again, I go back to, does everything need to be on the Internet? And the answer is maybe not. I'll give you an example of that. I've got a phone, and certainly my phone is on the Internet, but I also have a headset. My headset is not on the Internet. My headset, it's a Bluetooth headset. It's on its own little local network and so forth. So one of the things that we do see coming down the road is, yes, not every insert in your shop is going to have an IP address and is going to be online. It may be, though, that those inserts are going to have some local data transmission capabilities, back to your machine, or back to your local network, maybe Bluetooth, maybe Zigbee, maybe some of the Wi-Fi stuff. But these things are going to be online at different levels. And the question is, how do you percolate them up and how do you percolate them down, and what information do you pass back and forth? And a lot of that is going to really depend on what you're trying to do and what you really want out of this. And by the way, as you go off in this area, you're not going to need to be an expert. You just say, this is what I want. Maybe you'll get an app. Maybe you'll have some company that'll help you out, in terms of moving it forward, right, in terms of the data. But this information will go off to the cloud. I think there are some issues that we have to understand about the cloud. People are worried about all of their data being out on the cloud. And I think one of the questions you have to ask is, well, how secure do you need to be? How worried do you need to be about your data being out there? But the reality is the data will go out there. The data are of some value. And this is why, for example, the small and medium-sized enterprises will be engaged. I think, if you recall, I mentioned that for every OEM job, there are 8 supplier jobs. So you could imagine that there are a whole lot more, let's say, machine tools out there in these small and medium-sized enterprises than in the really big OEMs, okay? And so if you have a lot more machines out there, they're generating a lot more data, and that information could be quite useful. Let's say that you had a barcode reader, that you could read, you find out what inserts are going into this machine. And if you could put in a little bit more information on the machine that might say, well, I am machining 5100 steel, hardened to 55 to 60 Rockwell C. We know about some of these process parameters. Now you could learn about your toolware. Do you really want to know about the toolware? Bro, maybe not really. But maybe the company you're buying your inserts from would like to know how their tools are performing. Maybe somebody else could capture the data for a bunch of different machine tools running a bunch of different materials and processes and speeds, and could actually use that to generate feedback to you saying, hey, you're running this material, here are your feeds and speeds. And in fact, the value proposition might really be small and medium size, maybe it's a mom and pop shop. Let us have this information, and we will give you information on feeds and speeds. We'll give you recommendations for tooling. Maybe you should buy this tool instead of that tool, or maybe you should go with a ceramic or a CBN instead of a carbide, or a coated carbide tool, and the whole bit. So just giving you that information. Oh, and by the way, if we're tracking the tools and so forth, we could also do your inventory control. So lots of good stuff, And so, yep, we could sell this to you. And yep, now we have some information that we might be able to sell back to the tooling manufacturers, for example. So lots of good opportunities. Data out in the clouds. How proprietary do you want the data? It may not be, as critical as you think. And again, certain things will be more proprietary than other things. I think really where the big opportunities are, not so much in storing the data. As you can see, exabyte, that's huge, right? So you can see there you go from a megabyte to a gigabyte to a terabyte to a petabyte to an exabyte. And an exabyte is like bigger than, Google processes something on the order of 40 or 50 petabytes, I believe, a day, right? So this is like 20 times bigger than what Google processes, but it's out there, and we're going to have to deal with it. Okay, but again, I will talk about how things have progressed, in the end. The other thing I think is quite good is your analytics. And again, right now I've been focusing on just individual machines. But what if as you're learning, right, as you go along, you find out, hey, we can understand our processes better. What if I'm monitoring my spindle power consumption, and I know that I am, machining a particular, nickel-based superalloy, and I see that my power is much higher than I would expect. Now, this is something that you probably don't notice on the machine, but somebody else may monitor it. And in fact, we've done this in the past where we're monitoring machines and we get a reading off of the machine that doesn't make sense. In fact, what we've learned is, in one case we had the wrong material in there, so somebody shipped an incorrect material. In another case, it was just an incorrect heat treat on the material. So, you can be doing some learning, but again, you could even step back further and say, yeah, I understand a lot more about my process. So if we take a look at, how you move this forward, right? So now let's take a look at sort of the, collect, connect, store, analyze, and then really the next step is the utilize. And I think this is where right now, and I have to admit, I'm a little bit of a dinosaur here, because frankly speaking, if I really knew how to utilize it, I'd be out there utilizing it. But the reality is that there are a lot of data out there. We're going to utilize it in, I think, very traditional fashions. But I think what we're going to see in the not-too-distant future is we're going to see new ways of utilizing the data. And it's going to come along the lines of the same thing that we see in terms of apps for our smartphones and so forth. We're going to see people saying, hey, and maybe it's on Facebook or, chat or whatever it might be, I could really use this type of capability. I know at universities are always looking for, hey, give us some little projects and so forth. And we have students always working on small little projects, things like that. And people will do apps, that'll just run, and share data and move it back and forth and the whole bit and really link things together. And they'll be very low cost. You'll buy these things. Again, my smartphone has an accelerometer on it. I should be able to, and we've programmed it up actually, to put that accelerometer on my machine tool, on my spindle, and get vibration information. Now, it's a little bit what I would say, low resolution and things like that, but you can certainly get that type of information off of it. So we're going to see opportunities to utilize that information, and we're going to see opportunities to utilize it in very, very different ways, right? But one of the roadblocks that we will run into, on this utilization really is the translation. And so again, I got this from my colleagues over at MT Connect, in terms of the standards, right? And so we see a bunch of different machine tools talking different languages. I pinged them a little bit. I said, hey, there's no English there. And they said, well, there's no Japanese or Chinese there either. So we just picked, some different languages. But the idea really is we've got a lot of machines, and they talk a lot of different languages. And that is, really starting to change. Again, our computers, we might have a Mac, we might have a PC, we might have a Linux system, whatever, but they all talk a very similar language when it comes to Ethernet and the network. And that's really sort of that type of connection is going to start to happen, and we're seeing that happen already. And really what we need, I go back to my, this probably dates me a little bit, but, Captain Kirk and the universal translator, right? Basically, you need a way to universally move the data around. So we've got a bunch of machines, a bunch of, and a bunch of sensors, generate information. We've got to move that data around. Those data will be universally translated. There are, there's always this issue of, well, we're going to keep our data proprietary, our controller's proprietary, we're not going to open it up and the whole bit. You can try and do that, but basically the current generation of students, the current generation, our new engineers, our new culture is really everything needs to be open. So this is what people are used to. We are starting to see open architecture, open standards, like something like an MT Connect. And this is allowing us to do all sorts of things. And what's going to happen is if you don't move along in this direction, you're going to be left behind, in terms of the closed, architecture and so forth. So, we will look at things like, and again, I spoke about MT Connect, but, Bluetooth is very open, right? We've got Bluetooth standards, 1.2, 2, 3, 4, and so forth. We've got Wi-Fi, and then I think everybody's familiar with 802.11. A, B, G, N. I think there might have been a C out there. Now the new one is AC and so forth. And so we see a lot of connectivity out there. Although I hear Bluetooth, I hear some of my colleagues out in industry are saying, Bluetooth may have some issues in the factory and so forth. If that's the case, other things will come into place. Something like a Zigbee. Zigbee and Bluetooth are lower power. These are more local. Again, people are very familiar with that, and I'll show you some examples of how those are being used. Standards like MT Connect, right? That's specifically targeting manufacturing needs, right? So how are we going to get it out there? And I've picked this, particular machine tool. There are companies like Mazak who, are putting MT Connect on their machine. So it's there. It doesn't cost you anything. Now you can get all sorts of information. I'll give you some examples in a little bit about what's going on with the machine, okay? But even things like, is my machine up or down? Is my machine running? How much power is my machine using? And these types of things are very, very useful. And so now it's just an issue of accessing them, and you access them via the web, okay? But the reality is it's there for the taking. So it's not even an issue of, well, gosh, do I need to buy it? Do I need to get more sensors and so forth? It's there. The real question is, what are you going to do with it? All right? It's free. And I've heard estimates upwards of 90% return on investment, or I don't know, it's return on investment, maybe it's profit margin really, because all you really have to do is take the data and make use of it. That's it. It's there. Or they are there. Data is plural, right? My English professors and so forth always remind me of that. So again, you've got to open up the pipeline. I zero back in on MT Connect because there's a lot of good stuff out there, but whether it's MT Connect or Wi-Fi or any of these types of standards that will give you that universal translator. So I've got different machines, and they all have their own dialects and flavors of language, but they basically come out and say, okay, what information would you like from me? All right. And by the way, here we're really looking at one-way stream. My personal feeling is that initially it is going to be a one-way stream from the machine on up. There are a lot of security issues, and we'll touch base on those. But it's going to be a one-way stream, in terms of moving that data forward, as opposed to saying, okay, let's send programs and information back down to the machine to change its behavior. So we do have to be aware of that. So, in terms of the value proposition, let's just take a look at some of the bigger pictures. I already mentioned Google, Google Maps. So they're collecting a lot of data and so forth, and you're getting a value, and people run it. I mentioned the copy machines. Our copy machines are online. When that toner is low, it just orders a new toner for you. Now I don't have to worry about ordering a toner. Am I paying more for the toner cartridge? Sure, probably, but is it worthwhile? Yeah, it's a great return, because why? I don't need to, if I've got 200 or 300 copy machines, in my organization, I don't need to worry about paying, a couple of people to monitor, to order these things in the whole bit, to keep track of them. I don't need to worry about inventory control in the whole bit. Same thing on your manufacturing systems. And the other one, and I haven't actually gone back and verified this, but I was talking to a couple of my colleagues recently. They said, yeah, OnStar, there's some deal out there right now that, you buy a GM car, you get your OnStar going, and if you activate it, you get it free for 5 years. Now, again, I don't know if that's, don't run off and, sort of take a look at this the whole bit. I'm not sure if that's true, but I wouldn't doubt it, because here's the deal. There's the realization, there's one business model of we're going to make money by, selling OnStar services. On the other hand, you can turn it around and say, hey, we're going to get a lot of information, off of this. So, almost certainly when you agree to use OnStar, you're giving all sorts of information about your car and its utilization and things like that. That's very useful to a company like GM. Even if it's in terms of the health of the car, the performance of the systems, and so forth. This is all useful information. And data are big data are big dollars. They're very, very important out there. So, with that in mind, let me just give you a couple of examples in terms of some of the things that we're seeing and what we're doing. Just simple things. And just to sort of spin you up on some of these. So. We're looking at just some of these microcontrollers. It could be a PIC, a peripheral interface controller. You might have, and by the way, go out to any of the DIY, do-it-yourself sites. You see PICs and Arduino. MyRio is a National Instruments product. It runs LabVIEW, et cetera, et cetera. And so we've got these low-cost processors that are just everywhere. Okay, and we have different types of communication, Zigbee, what might be known by XB, Wi-Fi, Bluetooth, and so forth. And here are a couple of different projects that we just had running over here at Georgia Tech, where we're linking things up. Things like coolant temperature monitoring. By the way, I should point out that most of the modern machine tools today are monitoring their own coolant temperature. We have a number of machine tools. Again, I go back to MT Connect because it just makes life easy. I can go to the machine tools that are running MT Connect and say, hey, give me the coolant temperature. But let's say you don't have it. So, what we have here is we basically have a little, couple of dollar temperature sensor. It's a standoff sensor. It's IR. It looks at the coolant. It's not embedded in the coolant. It's not in the coolant. We've got a little Arduino and these are high school students are programming these things. And then we have a little Wi-Fi module, And so, so this thing, students, put it on the machine. They put it on the machine, wired it up, linked it into a TCP, just to a server, in the system, up on the Wi-Fi. And in fact, what's really pretty cool, in terms of just where things are going, so NFC, near field communication. The little picture, you see the hand holding the little, I guess that's the Google Droid, right? We get these things for about $1. I think they're 99 cents, and we're only 99 cents because we're only buying 10, right? But stick this on the machine. I tap my Android, whether it's a tablet or my smartphone, on this thing, and it tells the smartphone where to go to get the temperature plot of my coolant, so I can see what my coolant is doing. And this thing is stored off in Google Docs in a dynamic doc. It's all on the web, on the cloud. Everybody has access to it. Whatever you want to have access to it, you can share it. And by the way, all of that stuff is happening for free. Now, yeah, if you need more space, Google gives you, I don't know, several gigabytes, or I forget what it gives you. Yeah, if you want your exabyte, you're going to pay for it. Okay? But that being said, you can get things started. What they're doing, right, is they're giving you a little taste. And once you're hooked, yeah, you're going to pay a little bit for it. But, we're not talking much more than what you're paying for your cell phone or what you're paying for your broadband connection. And again, I think if you take a look at what you pay for your broadband connection and for your cell phone, it's a whole lot more, on a monthly basis, than you would pay for, you just pay it on a monthly basis or a daily basis or something, so fairly low cost. We're looking at spindle vibration monitoring. Again, same type of thing, little accelerometer, we have it on Wi-Fi, it goes off, and we can actually monitor, and this is what my, let's see, well, I'm sorry, and then we're using a Zigbee communication for this. So again, these are a couple of bucks. They're available. Kids nowadays know how to use it, so you're going to be building these small little platforms. And on my smartphone, and this is right off of my smartphone, I can see this is a spindle spinning at, 3,000 RPM. It's a 50 hertz signal. And then I told my student, well, hey, if I have a crash, what I'd really like to do is, get a little red, red flag saying, hey, my spindle crashed. And the student's like, yeah, cool, we can do that. So here's my little red thing saying, my spindle just, had a crash. And in fact, what they did is there's a webcam that we're seeing what's going on in the lab and so forth. And when the spindle sees a spike, and you can see my student Stephanie down there, she's actually banging the machine, which sets off the thing. And they said, we can also have the camera in the lab, which is independent of the machine, snap a picture to say, hey, who's crashing my machine? So lots of stuff can be woven in, really nicely and easily, and the whole bit as we move forward. Even things like, and one more example here that we'll take a look at, even things like, here's a Marpos gauge. So this is a diameter monitoring gauge for 3 feet centerless grinding operations. This thing just takes a look at the diameter. But it turns out, if we take a look at the output of the Marpos gauge, it's 2 sensors, and both of those sensors will give you, that's the type of reading you're getting. It looks an awful lot like a roundness plot. And in fact, yeah, so off of this gauge that was, from the, 1970s era that we're running on our grinders, we can get roundness information. And though, by the way, we can also take a, FFT of this thing and see we got 31 UPR. So here's the sensor that's 30 years old. It's giving us roundness information now, and so now we're getting more data out of it with, again, just taking the electrical signal and processing it. Very little more investment in terms of hardware. Let's just get it out the door. And again, if that information is coming into my machine and my machine is MT Connect or some other communication protocol, off it goes to me. All right, so these are the things that we look at. But it's older technology. All of our plants have the whole communication network and so forth. So the infrastructure to pull this off is relatively easy. It allows distributed control and communication. That's what Ethernet is all about. So it's easy. Everything is in place to do it. It's just a matter of doing it and thinking a little bit, and sometimes a little bit outside of the box. But I will tell you this. I mean, history. This is all about history. Back in the 80s, we went from the LP to the CD, data compression and so forth, got us to where we are today in the music industry, completely revolutionizing how things work. I think back in 1980, in the early 80s when we went to CDs, people have never thought of where we are today. Took a little longer with 2D because it's a little bit more memory. It's actually, instead of 10x, it's 100 because it's two-dimensional, so 10 times 10. But people said you'll never replace, like they said, you'll never replace my LP, you'll never replace my Kodachrome. And now it's been done, right? And in fact, I'll just give you, if we put, instead of just pictures, we do videos, and you want to look at business models and how rapidly things can change, I'll give you Netflix and Blockbuster. And that's how fast things are going to change. The same thing is going to happen in 3D, in terms of manufacturing. And big data is really going to enable it. New business models, right? So I think a lot of the things that we're thinking about is still inside the box. Talked about inventory control, but we're looking at now rapid development of parts. How are we going to improve our machine utilization? How are we going to expand our knowledge base? How are we going to integrate with the supply chain? There are a lot of opportunities out there, and we haven't even talked about, this is maybe down the road, integrating with high-performance computing, right? So we've got lots of different opportunities out there. We had our digital tools talk not too long ago, integrating all of this together and really scaling it up. This is what it's going to be about. And again, I cannot stress, even more the data out there. So let's take a look at a couple more slides where I turn it back over to Pat. No, I'm running long, but I get excited about this stuff. Look, the roadblocks. There's a lack of standards. We are moving to rectify that. We are getting it out there so that, you're not going to be all over the place. You know how to access these things. I think a big roadblock now, I think standards being addressed. If you haven't had a chance, look at something like an MT Connect. Out there, makes life easy. Thinking in the old way, what's the value proposition? Again, I don't want to let my data out there. Why should I open it up and so forth? It's not about keeping the data to yourself or selling the service. It's about, I'm going to give the service away so I can get your data so I can help you, and that's your value, but I'm going to also have the data that I can make use of. That's where you're going to make the money. And I think it's going to be a lack of experience, and particularly for the small, medium-sized shops, you got to get those kids who know all about the Arduinos and the nets and whatever it is, into your facilities. They are very comfortable with technology, okay? And by the way, it's not only the kids, it's your workforce. You got to get them into the 21st century. So, you've been out there for, several years, you got to keep up to speed on what's happening out there. The other big roadblock, and make no mistake, this is a big issue, and everybody is thinking about this, is security. You think it's bad if you get a virus on your computer. Wait till you get it on your, $500,000 machine tool, right? And so there's a lot of thinking about that and so forth, and how are we going to secure it? I think the bottom line is we cannot go backwards. I don't think anybody is saying, well, I'm going to get rid of my connectivity or I'm going to get rid of my computer because I'm afraid of a virus, but we've got to work on that. Security is going to be very important. If you've got a virus that crashes your computer, it's one thing. If it crashes your machine tool, it's a completely different thing. So, key thing here, okay, I'll go back to my Star Trek one. I was enjoying myself with the whole Star Trek thing. I think you don't want to be, you see those two guys in the red shirt? If anybody has seen any of the old Star Treks, and again, I'm dating myself, those two guys on the landing party, who you never saw before, you're never going to see them again because they never, ever, ever survive that landing party, right? And that's what you don't want to be. You don't want to be the no-names. You want to be the people who are taking the lead, understanding what's going on, and adopting the technology. And by the way, you're not adopting technology. It's just like your cell phone. You're not adopting technology that's here to stay for a very, very long time. It is going to be changing rapidly. So in terms of wrapping things up, it is about, and there's my friend the KUKA, Titan robot, and that thing, it's got sensors on it. It gives you all sorts of information about your process and so forth, and it's doing jobs that people don't want to do anymore. And it's creating jobs that people will be doing if they have the right training. But it is about wealth creation. We can do it sustainably and efficiently. And in fact, with the big data, we could be much more efficient. It's about enabling, the small and medium-sized manufacturers. So, The big guys get it, and they are moving forward on it. But we've got to get this down to the smaller guys. This is where the success is going to be. This is going to move the nation forward. Okay. By the way, it's also going to move the whole world forward. But look, in terms of the infrastructure, everything I'm talking about, it is in place in the United States. And this gives us a significant advantage. With the United States of America, really what it's going to do, it's going to allow us to be very innovative, very flexible in terms of manufacturing, and it's going to allow us to do the things that we need to do. But in terms of the world, it's also going to keep the world humming along and better integrated. Because, again, one can say, hey, we're going to bring all the manufacturing back to the United States. That's not a very good solution. Sounds good, but you need to have other parts of the world that are doing well, and producing things and so forth. So the whole globe is a happy place. If you have people with good jobs around the world, they're not doing other things that might make the world a little bit less safe place to do. So my last thought here, and I think this is very, very important, it's about education. And this is a quote from Eric Hoffer, and if you've heard some of my seminars, you may have seen this before, but in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. And I want to stress this point tremendously. Manufacturing and technology have changed rapidly. You are in the workforce now for 50 years. Think about what technology was like 50 years ago. NC, maybe even a little bit pre-NC, right? And by the way, that rate of change is accelerating. It is not good enough to say we're going to hire some new talent and bring them in and they're going to sort of keep us going. We have got to make sure that our current workforce is also engaged on the educational level. So it's got to get back to lifelong learning. So on your human resources side, if you walk away with one thing here, make sure that you keep people learning, keep them moving forward. Not rocket science, just make sure they're not afraid of the technology, they know how to use that technology. And by the way, if they're comfortable with it, they know how to use it, my guess is that some of these people may figure out how to think outside of the box and make you some significant bucks. They may be the next YouTube or the next Google, and that's the way it's going to come down. So with that, I will thank you for your attention. I'm going to turn it back over to Pat, and maybe we'll have a few questions. Thank you.
Hi, this is Pat Wozniak joining you again. Thank you, Tom, for that very informative session. We have received some questions, and it would be nice to get to all of them before our time is up. Tom, here's a question. What's the value proposition for the small shop?
So, again, the small shop, has only so much expertise and capability and so forth, right? So if you're a big player, you've got lots of engineering and you can move this forward. So for the small shop, again, it's going to be getting back to, going out. The small shop, they want to make, for example, parts. They want to make parts, right? And so maybe they don't have a lot of expertise in data analytics, even things like inventory control and so forth. That can now be, given to another company. So the data can go out. The other, somebody with the expertise and the capabilities can work on it, even using things like supercomputers and high-performance computing and all these advanced models and so forth. They can take care of that for you, right? It's just like, in the old days, right? We used to go with travel agents and so forth. Today, you may say, well, I don't do that. I go to, some web-based system. But you're still going out there and using somebody else's expertise. So the real advantage here is now you can bring in, and by the way, at very low cost, expertise. And in some cases, that expertise will come to you, for free because you're providing data that, that person who has the expertise can use to really leverage somewhere else.
Tom, how does this fit into manufacturing jobs?
So here's the thing, and I think it's very important to understand. People say, well, manufacturing is coming back to the United States. Number one, the United States has for a very long time been the number one manufacturing economy in the world. One could argue now that China is number one and the United States is number two, and China will ultimately be bigger, no matter how you're going to look at it, than the United States, primarily for domestic consumption. They just, they can't build enough cars for themselves. Now, that being said, manufacturing, there's been some offshoring, and now we're seeing reshoring, and that seems to be accelerating. But the same jobs are not coming back to the United States. These jobs that are coming back are very high-tech, very value-added jobs. And so what big data is going to enable are more of these types of jobs. So, again, it's going to come back to education, and by the way, I think it's okay. You know what? If I'm now retiring at age 70 or 75, do I want to really be picking up a tire and putting it on a car on an assembly line. I don't think so. At 70 or 75, I want to be programming the robot that does that, right? And so these are better jobs, they're higher tech jobs, but they're different jobs. The other thing I'll point out, I've seen numbers floating around, something like 60% of the jobs, so the kids born today, 60% of the jobs that they will be taking when they enter the workforce don't exist today. And if that, you're scratching your head on that, think about 20, 30, 40 years ago and a computer programmer or a data processor, right? Were those people around 50 years ago, right? Was there a CNC programmer? No, right? So those jobs are coming. They're going to be high tech. They're going to be much better jobs. They're going to really fit, what goes on in the United States. But it's going to be different.
Tom, what do you suggest manufacturing professionals do to keep up with the change in the digital portion of the industry?
So I think a couple of things, that are going on. So, by the way, things like this webinar are just wonderful. You just see what's going on. And all of a sudden you realize, some of the big data in manufacturing, it's not different than Google or OnStar or how my copy machine works. So get out there and just listen to what's going on. Do you really need to know the details about implementation? No, there are a lot of opportunities out there, but certainly continuing education, these webinars, if you have opportunities, even, at universities, if you're close to university, look at some of the seminars that they're putting on. Even participate, in some of the design classes and so forth. But just go out and learn about some of the new technologies. And, professional societies like Society of Manufacturing Engineers, is great. They're great in terms of what they can get out to you. The other thing is, go to your suppliers. Hey, go to, your machine tool vendors and say, well, what do you have to offer me? How is this going to help me? How am I going to set it up and so forth? So you can get some comfort level with that. So I think lots of good opportunities out there, but it just takes a little bit of, keeping spun up on things.
Tom, can you expand a little bit more about the critical issue of security?
Yeah, so again, security is a very, very important thing. And in fact, if you take a look at something like MT Connect, which I've touted a fair amount, but it's a very nice standard. I mean, it's out there and it's working the whole bit. It's a one-way street, right? So it's only sending data out, right? And there are different levels that you have to think about in terms of security. One of them is, how do I protect my data? So, if it's streaming out there, well, maybe people could crack in and get it. But the other thing you have to be careful about is, what people could do to get into their machines and so forth. And we've all read about things like the Stuxnet, virus and so forth that destroyed, the centrifuges and so forth over in Iran, et cetera, et cetera. You have to be careful about these things, right? And, you see what's going on, for example, with Sony today, right? And, so they've, been invaded in the whole bit. So, yep, the viruses are out there, damage can be done, and so forth. You have to be careful about that. People are still thinking about it. It is a different level, but it's something we're living with already, right? So it shouldn't be something where you say, well, John, I don't want to do it because I'm afraid of it. All of your business operations are already out there. All your communications, the whole bit, they're already vulnerable, right? So people are, running their antivirus programs and their professionals out there and so forth working on it. Is it perfect? No. Will there be holes? Sure. The only hope really is that, we continue moving forward. But the virus thing, and the security, we're living with it today. We're doing quite well. I go to an ATM machine, it accesses all my accounts, and in fact, no matter where I'm in the world, I stick my little card in there and then, and I can pull funds out from my account in whatever currency I'm at, and it knows, it's linked into the system because it knows, how much is left in my account. It gives me that information. So it's a concern. It's something we need to be vigilant about and we need to watch, but it's also being addressed, and I don't think it's a showstopper. We've got to move forward on it.
Thank you, Tom. Unfortunately, our time is almost up. All unanswered questions will be passed along to Tom, and you can expect a reply via email. The entire webinar will be available for replay by 4 p.m. Eastern Time, and you can access it by using the same sign-in link you used today. As Tom has shown, manufacturers can achieve significant improvements using advanced manufacturing techniques, leveraging the latest software programming solutions. SME and advanced manufacturing media have a host of ways to keep in touch with the latest developments in software and manufacturing technology. For instance, our October issue of Manufacturing Engineering included a special software supplement. The December issue of Manufacturing Engineering included a feature article on CAD/CAM software for mold and die manufacturing. Every issue of Manufacturing Engineering includes a software update section featuring a Q&A interview with software industry experts. Archived issues of Manufacturing Engineering can be found at sme.org/digitalmemag. Manufacturing Engineering delivers the latest controls and software news and information found on our website at advancedmanufacturing.org. Thanks for joining us for this Advanced Manufacturing Media webinar. We hope you found it informative.